जिनिवाति दीनाम् अवित्रवतु।
Okay, welcome students to this class of Introduction to System of Linear Equations. Okay, there is no fun in learning unless we know the use of a topic, that is why we are learning. So first we see where system of equations are used. System of equations are used in biological sciences. Now this don't look single word. There are lots of things in it: botany, zoology, microbiology, life sciences. In all those system of equations come medicine. We use system of equations in medicine, mechanical engineering. Okay. So if an aircraft is to be designed or a machine is to be designed, how you will design it? There are various factors which you have to see when you select a metal, the material. Okay. So aircraft ka material, it should be of what kind of metal or a mixed alloy. It should be able to bear extreme temperatures, very cold and very hot. Okay, it should have a light weight so that it can take off with very little fuel. Okay, etc. Like many other factors of this kind are there. Still, it should be very sturdy. It should be able to carry lot of passengers safely from one country to other. So, looking at all these factors, we frame these conditions into what is called a system of equations. Fine. Exactly similarly, then we have robotics as another branch where it can be used. And like this, the list is endless. Almost everywhere, I will say, system of equations are useful. Fine. So now, after seeing that where it is used, let us come to what is a system of equation. Well, we have system of linear equations, something which represents a line, or more generally a collection of lines, that is a plane. So it cannot have square, product terms, quadratic, cubic terms. It will have only degree 1 and degree 0, that is constant term. So I have given here this example, this first example, 2x minus 3y plus z equal to 3. That is one part of this system of equations. Second equation here is 4x plus 7y equal to 12. So how we describe this system of equations is there are three variables x, y, z, and there are two equations, first equation and second equation. Now you may feel here that z is missing in the second, but we can very well take it as a 0 condition. Yeah? The second example, though, which is written here, though it is a system of equations, it is not a system of linear equations because of the presence of the square terms and this product term of x into y in first equation, and even in second equation there is sign. That also is not acceptable. Right? So we have understood what is a system of equation. Right? Now we come to what is meant by solution of a system of linear equations. By solution, what we mean is those values of variables will satisfy each and every equation. So let us talk about this system which I have taken as example here. 2x plus 3 minus 3y plus z equal to 3, 4x plus 7y equal to 12. I want those values of x, y, z such that the first equation is satisfied, and by the same set of values the second equation should also be satisfied. So a common collection of values, a common set of values of the variable which satisfies each and every equation in the system is called as a solution. Okay. So to find a solution there are several methods. One of them is graphical method. So we draw a graph and from the graph we can find the solution. Another method is elimination. In elimination method, we eliminate one of the variables. If required, we repeat the procedure, we eliminate one more variable. So that now the system becomes of a lower number of variables, and all of you are familiar with how to solve a system in two variables, solving simultaneously, is the commonly used term. Okay. So if you reduce the number of variables, it's very easy to solve through elimination. Elimination method is very nicely modified by Gauss and it is called as Gauss elimination method. Okay. And also there is a method called as Cramer's rule. However, there are lots of conditions in Cramer's rule, like the first condition that itself is number of equations and number of variables must be equal, which means, see, the system which I have taken does not have equal number of variables and equations. 3 variables, 2 equations. Cramer's rule is not useful here. Okay. So we come to the other methods one by one. We will discuss the first 3 methods here in this class. Let us see the graphical method first, which also gives you the geometric interpretation of the system of linear equations. Basically, we can categorize existence or non-existence of solutions into 3 different cases. Now here, sometimes the system of equation may not have a solution. It is not that by these methods we can always find solution. Sometimes the conditions, the equations do not agree with each other. See, if I tell you x equal to y and x equal to 2y, you will be able to get only one solution, 0, 0. So sometimes you will not have good solution. 0, 0 means don't do anything. If you want 0, 0, the specific gravity of a metal which you are using for aeroplane, that means you can't actually go for a real work there. Right? So sometimes the solution may not exist. Such system we call as inconsistent system. And if solution exists, we call it as consistent system. Okay? So if solution is there, consistent system. If solution does not exist, inconsistent system. Let us look at the first diagram here. This is a case where no solution is there. Now the system which is under consideration here is of 2 variables, 2 equations. First equation is x plus 2y equal to 6. Second equation is also x plus 2y equal to 4. Fine. Now if I graphically try to plot these are nothing but straight lines in R2. You can see the first equation I plotted here as this line, marked as 1 here. Okay, it will have intersect 6 on x-axis, 3 on y-axis. Similarly, the second line is plotted here. Actually, if you see, they are nothing but parallel lines. Their slope is same. From here you can see. Correct? The slope is same of both the lines. So they represent parallel lines. Now what is the solution? Something which is common to both. There is nothing common to both because parallel lines do not have any common point. And therefore this is the case where there is no solution. Okay, this is an inconsistent system. Okay, graphically, when you are taking 2 variables, an inconsistent system has 2 parallel lines. Right? Come to the second case, unique solution. Exactly one solution. Okay, I have taken the system here as x plus 2y equal to 4 and 2x plus 3y equal to 7. On solving simultaneously, of course, you can easily obtain the solution as x equal to 2, y equal to 1. Now let us check graphically what happens. Plot the first line, put x equal to 0 and you get value of y and y equal to 0 and value of x. So these are the 2 lines which are plotted, which represent first equation and the second equation. They intersect in one point here. That point is common to both. Correct? Point of intersection is a point common to both the lines. So that is a solution. No doubt this 2, 1 which I have shown here, the point of intersection is a solution because it is a point on both the lines. No other point is on both the lines, only one. That is the only point which is common to both the lines. And therefore that is the only solution. It is a solution and it is the only possible solution. Hence unique solution. Unique means one and only one. Okay, so this is the case where we have a unique or exactly one solution. Let us come to the third case, infinite number of solutions, infinitely many solutions. The system under consideration for this purpose is x plus 2y equal to 4 and 2x plus 4y equal to 8. Okay, when I try to plot, actually the two lines coincide, overlap. That means each and every point on this line is on both these lines. Because the two lines actually, graphically when you see, geometric representation of both these lines is this common line. So every point on this line works as a solution. And how many points are there on this line? Infinitely many. So we have infinitely many solutions in this case. You will be surprised to observe that we do not have finitely many solutions case. Unique solution is only the case of finite. There is no system which will have 6 solutions or 7 solutions or 25 solutions or 90 solutions, which means finitely many, only one solution. The moment you are able to find 2 solutions for a system, actually there are infinitely many solutions. You will never have just 2 solutions. Either only one or infinitely many solutions. This is the beauty of system of linear equations. You never have finitely many, greater than one finitely many solutions. Okay? So we have dealt with the first method, that is the graphical method. Next I will show you elimination method. How to use the elimination method. So consider 2x minus 3y plus 4z, and one more equation I will take, 3x plus y plus z. Here there are 3 variables. We will eliminate one of them. Any one of them we can eliminate so that only 2 variables remain, and then we can easily solve. Okay. So for eliminating, what you can do is you can multiply. Yeah, correct. Either you can multiply by 3, second equation, or 4. So then one of the variables will get cancelled. Multiply second equation by 3 and 1 plus 2 will eliminate 1. And then it can be easily solved. However, we are not going more detail into this manual elimination, because the Gauss elimination is much more refined, sure shot and quick method. Now, Gauss elimination method is based on what are called as row operations. There are 3 main row operations which are to be used when we are using the Gauss elimination method. So, it is also called as elimination method because actually we are eliminating the variables and we cannot see any of the variables there, because we are using the matrix representation of the system of equations in Gauss elimination. So what are important are just the coefficients and the constant part. The x, y, z, etc. will not be written every time because they don't undergo any change. See, when you have done multiplication, do x, y, z go under any change? No. It is only the coefficient and the constant part which undergoes the change. So we do not write those. Okay. So let us come to solution using Gauss elimination method, which does not have any condition on the system of equations. You can use it for any system. Gauss elimination method. Mainly there are three operations. Let us first understand with the example of the system of equation itself. Does it really make any difference if I write the second equation first and the first equation as second? No. It does not really make any difference, which means the order of equations in which they are written can be exchanged. Now, if I write the coefficients in a matrix form, equivalently it means that the rows of the matrix can be exchanged. And second thing which we have done is, we have multiplied second equation by 3, correct? That means any equation can be multiplied by any non-zero real number. That is our second operation. And third is, we can add multiple of one equation to the other equation. Now, talking in terms of matrix representation, we have these three operations, elementary row operations. They are called as, first is exchange any two rows, multiply any row by non-zero real number, and third is add multiple of one row to other. We can add multiple of any one row to another row. Performing these three operations, we can very easily obtain solution of any system of linear equation. Okay? Meaning, if it is solvable, if it is inconsistent system, nobody can create a solution for you. Even Gauss elimination method then can't give you a solution. But yes, it will tell you that there is no solution. That provision is also there in the method. At certain step, you can identify that it is not going to have a solution. So, Gauss elimination method is one of the best methods for solving system of linear equations. Fine. We will consider one simple example to see how this method can be used to solve a system of linear equations. So now I am considering the system A plus B plus C plus D equal to 4, 3A plus B minus 2C plus D equal to minus 1, and A plus 2B plus C minus 2D equal to 3. We will write a matrix for this, which is called as augmented matrix. Augmented matrix is denoted by A star. A and asterisk mark, which we commonly call as star, A star. We collect the coefficient of each and every variable in every equation. So the first equation has coefficients of the variable as 1, 1, 1, 1 respectively. Then in the second one, 1, 1, and last one, 2. We don't stop there. We have this constant part also attached over here. Because whenever you are multiplying this equation say by 5, this will also get multiplied by 5. So we consider this also as a part of our, and due to this only we call this as augmented matrix. Coefficient matrix is only this much. It is because of the last column that this is called as augmented matrix. Okay? Augmented means enhanced, increased, extended. Fine. So now let us try to solve using those operations. Now those three column row operations you have, but then how should you use them so that the solution is quickly found? Well, the key is we try to make the entries below the triangle, the diagonal, this triangle part, we try to make the entries as 0. Have the diagonal below that, try to make these entries as 0. So we are aiming to make these as 0. So I suggest the first operation to be performed is second row minus 3 times first row, so that this entry will become 0. Okay? So second row, how is this written? See, R2, second row minus 3 R1. R2 minus 3 R1. So let us quickly write down what are the entries then? 0. This will become 0. Minus 1 minus 3 is minus 2. 1 minus 2 minus 3 minus 2. Minus 2 is minus 2, and minus 2 minus 12 is minus 13, right? And last row remains as it is. We are not doing anything on last row at the moment. Now it is the term of the last. This one we want to convert to 0.
R3 minus R3.
Exactly. It is R3 minus R1. So if you do R3 minus R1, what you obtain is 1 1 1 1 4 0 minus 2 minus 5 minus 2 minus 13. This is 0. We have aimed at the 2 minus 1 will be 1. 1 minus 1 will be 0. Minus 2 minus 1 minus 3. 3 minus 4 is minus. Are we through? Finished the task? No. There is one more entry. We want to make 0. Okay? Now, we have two options. Either we consider minus 1 by 4 to 1/2 times this here, but that may involve fractions. Rather than, I suggest we interchange first and second row and then carry out the operation. So, the next thing is R2, R3 interchange. This is the sign that we use. R2, R3 is mutual exchange. After this, what you obtain is 1 1 1 1 as the first row. Extended part is 4. 0 1 0 0 1 minus this is the calculation that we require now? Yes. So what you obtain after this? 1 1 1 1 4 no change on second row. This third row only is undergoing change. So what you get now? 0 minus 5 plus 2 times 0 that will be minus 5 minus 2 minus 6 so minus 6. Now it is minus 13 minus 2 minus 15. Alright, so we have completed our work of using Gauss elimination. Now we are ready to take the solutions out from this. Start from the bottom row always, the last row, because that is having maximum number of zeros. So always start with the last row. This was for x, y. Okay, first variable is ABCD. A, B, C, D. So for minus 5C minus 8D equal to minus 15. there are two variables. So for one of them we take a virtual value, say t, which we call as not a variable. A parameter t. Parameter means we will be able to use any value for t. Any real value, 0, 1, minus 1.2, root 3. Any value of t is usable. At this step is indicating that we are going to have infinitely many solutions. Parameter is there. Parameter has how many values? Infinitely many. So solution will be infinitely many. Okay? So C value we will get. T value we have got. T is a parameter. T. Value of C we can find from this. Minus 5C is 8D minus 15, which actually is 80 minus 15. Substituting B equal to T. And therefore, C equal to 8 upon minus 5T plus 8. Now let us use the second row. Using the second row, B minus 3D equal to minus 1. So that is equal to B equal to 3D minus 1. So that is equal to 3D minus 1. We have completed finding the value of B also. Now only A remains. So finally we are using the first row and we get A plus B plus C plus D equal to 4. That means A is 4 minus B minus C minus D. That is 4 minus, I put B as 3 minus 1 minus C was minus 3 is equal to 3. Let's simplify this a little bit. So it is 4 minus 3 plus 1 So you can simplify this to minus 3t minus 3 plus 8 upon 5 minus 1 into t plus the constant part is 4 plus 1 minus 3. So we can simplify this, get the coefficient of t.
12 by 5t.
That will get us 12 upon 5t plus 2. That is the value of A. And so now we are ready with typical solution. What kind of solution the given system will have? This is called as general solution. General solution S, that is equal to A, B, C, D, where A is 12 upon 5t plus 3, B is
Plus 2 is
3t minus 1, B is 3t minus 1, C is minus 8 upon 5t plus 3t, and D is 2. We break this into two parts. One is involving the parameters and other is a constant part. So this will be 12 upon 5, 3 minus 8 upon 5, 1 times p. T we have taken common way plus
3
now constant parts 3 minus 1 3 0 exactly.
Now it must be 2 in second line. T 12 by 5 T plus 5 T plus 2.
Which one? Second?
Value of T plus 12 by 5 per is 2.
2. Okay. Put any value of t. Simplify this, add that, and you get a solution. One solution is already ready-made before you. If you put t equal to 0, this part vanishes, and this is directly a ready-made solution in your hand. So, a equal to 2, b equal to minus 1, c equal to 3, d equal to 0 is a solution. Verify each equation. A plus b plus c plus d equal to 4. Is that true? 2 plus minus 1 plus 3 equals to 4. It satisfies first equation. Similarly, if you substitute in second equation, it will satisfy that also, third equation also. So this is one solution. If you put t equal to 1 minus 1, you will get many other solutions from it. Right? So this was an example of how to use Gauss elimination method using elementary row operations to find a solution of system of linear equations. Okay. Thank you.
Thank you, ma'am.
कॉलम्स यूज करने के लिए क्या कुछ लोग समझो क्या सेकंड कॉलम यूज करें मतलब सिर्फ बी के कोएफिशिएंट पे कुछ करते हैं that is not permitted. We are supposed to multiply the entire equation. The entire equation represents a row. Column represents coefficient of one particular variable. So we don't use the column. Okay.